Okay, I'd like to welcome everybody back to school, and I'm Dr. McNeil, and I've been selected to help you get ready for the Certified Electronics Technician exam. And this is a Steps 3 class. Steps 3 to Success is the official name of the class, but in this class we're going to give you some background and review a lot of concepts that you've had over the last almost 2 years, whether it be for an employee examination to get in so that you can get an interview. Quite often employers will give you a little test before they give you an interview to kind of thin out the people they don't want to have. And also, it's primarily geared towards the questions that you will find on the Certified Electronic Technician's test, so that you can be recognized for your skill set from a third party. It's always nice to see that on your resume. So, make sure that you've read the introduction, and it was the letter that I sent you an email. I'd appreciate it if you read it twice. There's a lot of information in there. And also, before you watch this video, it would be good for you to print out and have the handouts ready to fill in for week 1 before you watch this video. And that also includes the practice test as well. So make sure you have that ready to go. And if you have to, you can always stop the video, print them out, and then come back and continue it. That's the nice thing about watching this video. If you have any questions about anything that we cover in class, maybe I made a mistake and I didn't see it, please always remember to email me. Now, as far as the curriculum material goes, we're going to go from Tuesday to Tuesday. So on Tuesday, your video will become available to you, and I'll have the handouts and the practice CET quiz there ready for you to go. I'll cover the material, and once I cover the material, I will I'll make the answer sheets for the material, the guided outlines available to you later in the week, Thursday or Friday, and at that time, I will also turn on the online quiz, which you will have to complete before Monday night. And that will be your grade for the class. So make sure you try to pass every one of those quizzes. If you have any questions about that, let me know. I think in your schedule, it says that your class only runs 6 weeks or something like that. I'm not too sure how it appears in your schedule. But if you are not interested in taking the CET, you are still required to take this class and take at least 6 quizzes. The first 6 quizzes will be all the basic material, and you need a passing grade on those at least 6 good quizzes. So make sure you take the quiz on time. If you miss it, you get a 0 for it. And but I will still make the answers available for the quizzes. What you need to do is, to prepare for this class, is to create a test bank of all the practice quizzes and all of the quizzes. And those are the actual kind of questions. Not exactly, but they're very similar to what you will find on the CET or employee entry examinations. And the way you should handle that test bank is cross off all of the quizzes that you got right, all the quiz questions you've got right, and circle the ones that you didn't get right, and study only the ones you didn't get right. You don't have to study the ones that you did get right. It's a waste of time. Study only the ones you didn't get right. Then go over them again and look at those questions and see if you can answer them correctly. And if you can, cross off the ones that you did circle. Eventually, you're going to know every one of those questions. Okay. If you have any questions about the class itself, make sure you email me and let me know. Let's go ahead and move on and begin. Okay, your first handout should say Resistance Fundamentals on it. And there's some very, very basic stuff. This is really nice for you to review. For example, how do you find the resistance from a color code on a resistor? Well, there's 4 stripes there. The first 2 numbers of the striped colors, and you got to know those color codes, are the first 2 numbers of the resistance. And then the 3rd number tells you the number of zeros. The 4th stripe tells you the tolerance. And what are the tolerance codes? Well, we know, you know, if you think about all the different colors, well, the tolerance codes are what? Let's see here. Red is 2%, and gold is 5%, and silver is 10%. And if there is no 4th stripe, that would be 20%. Rarely do you see a 20% resistor anymore. Now, how do you find the minimum and maximum value of that resistor given the tolerance? Well, you take the resistor value and you multiply it by the tolerance in percent, and the percent will be in decimal form, and you add it and you subtract it from the resistor's value, and that gives you the min and max value. So that's how you find the tolerance. Now, quite often the test will ask you a question about tolerance. They'll give you a color code, and then they'll ask you which of the following is within the tolerance. Well, that's an easy one to answer. You don't have to go through all the math. You don't want to waste time. You're only given about 1 minute per question to answer these CET questions. So what you want to do is you figure out the value of it from the color code, and then you just pick the closest value from the 4 or 5 that are listed there. For example, if it's a 2K resistor, you just pick the resistor value that is closest to 2,000, and then you'll have the right value. Because all the other ones will be further out, and they're just asking you for one particular value. You'll see them in the sample quiz today. All right. Now, think about, I believe that there's a handout in there about wire gauge. If not, you can pull it up on the internet about wire gauge and resistance and size. And the American wire gauge tells us the thickness of the wire. And the odd thing about the American wire gauge is that the gauge number, or the AWG, there's a number to it. And if the gauge number is bigger, if you have a bigger number, the diameter of the wire is going to be smaller. So the diameter goes smaller. Okay, so what happens to the diameter of the wire if the gauge number increases? Well, the diameter gets smaller. For example, a 12-gauge wire is much thicker than a 30-gauge wire. 30-gauge would be like the telephone wire in your home, and 12-gauge might be the house wiring in your home. So as the AWG number goes up, the diameter goes down. Now, how does the diameter and the resistance relate? Well, if the diameter goes down, what happens to the resistance? Well, the resistance goes up. So let's make a statement here about the AWG, the diameter, and the resistance. Well, the gauge number is inversely related to the diameter, but it's directly related to the resistance. So that's the relationship of wire gauge, resistance, and wire diameter. They will ask you some questions about which one has the higher resistance, which one is a larger wire by going by the gauge number. So you will have 1 or 2 questions like that. And there are 100 questions on the test. And I may as well just tell you this now. If you get all the easy ones right, you're probably going to pass the CET exam. It's the easy ones that you want to make sure you do not miss. So you want to read the questions very well and read all the answers and pick the best possible answer, because there will be sometimes 2 or 3 answers that are right answer, but you have to pick the best possible answer. So be careful of that. Also, whenever you're answering these questions, if you see an answer that sounds good but you never heard of the words inside of it, for example, if you see something like buck boost or something like that that you've never heard in class, never answer with an answer that is something that you've never heard of, even though it sounds good. The CET professionals call that a distractor. It sounds good, but it doesn't make any sense. So watch out for those questions. Okay, what does the word continuity mean to you? Part of this class is learning about the different words that older engineers will use out in the field. And perhaps you didn't hear the word continuity too much when you were at PTI. Well, continuity means that there is a circuit connection, a conductor between the 2 points that you're testing. It's called continuity. And that actually means there's a short between those 2 points. If you look at your meter, you'll see on your meter you have a beeping function. When you use that beeping function on the meter, that's called a continuity tester. But also a continuity tester could be using the ohm meter on a very, very low ohm scale. So what does the word continuity mean to you? It just means there is a circuit connection between 2 points. Now, what equipment is used to test for continuity? Typically, to test for continuity, you will use a low resistance ohm meter, or an ohmmeter set to a low resistance scale, or the beeping function on your ohm meter. A lot of the good meters will tell you the ohms as well as beep when you do have continuity. Now, what kind of components will you check for continuity? Well, not only do you check for the connection of two wires, but it's very, very common to check transformer windings on the primary and the secondary with a continuity tester, because what are those made out of? They're made out of inductors. And what are inductors made out of? They're made out of turns of wire. So what do you read when you measure the resistance across a bunch of wire? Well, you're going to read some low number of ohms. It's called a continuity check. So inductors, or just checking the connection of two wires when you're building a panel perhaps, or checking the primary and secondary of transformers, those would be used. You could use a continuity checker to check that. All right, moving on. There are some basic questions about thermistors and how thermistors react. If you've never heard of the word thermistor, you should have been exposed to that in some kind of control class, whether industrial control or in control electronics, for those of you that were in the broad base. A thermistor is what it says, a resistor that changes according to heat or cold. So therm, like thermometer, resistor, and that's where the istor comes from, thermistor, a resistor that changes with temperature. That's what it is. Now there's two kinds of thermistors. A PTC, which stands for positive temperature coefficient, positive temperature coefficient. And the way that you want to think about the reaction of a PTC is, when the temperature goes up, the ohms or resistance goes up. So in a positive temperature coefficient, the resistance will increase with heat. That's how you want to think about it. When you're talking about the reaction of a thermistor, if it's a PTC or if it's an NTC. NTC means negative temperature coefficient. Well, what that means is, when the temperature goes up, the resistance goes down. So for a negative temperature coefficient, when the temperature goes up, the resistance goes down. Now, I'll give you an example of these over here actually are some thermistors, and here's different kinds up here as well. But you see, this one here actually has a NTC written on it, but sometimes they don't, and you kind of have to check them or get the number off of it and check it on a minute to see what it is. But what kind of electronic devices are PTC? Well, MOSFETs are positive temperature coefficient. I don't know if you've ever listened to a high-power audio amplifier. Maybe you're in somebody's car. A lot of them are MOSFETs. MOSFETs will cut back on their conduction when they get hot. So they kind of protect themselves. So they are positive temperature coefficient. What is a negative temperature coefficient device? Well, that would be a basic BJT transistor. When the temperature goes up, the beta goes up, which makes the resistance go down, and that makes more heat. And more heat increases the temperature, and the resistance goes even down further, creates more current, more heat. Eventually, it goes into what we call thermal runaway. Now, in control systems, you learn that these kind of devices are actually used to measure temperature. They give you more or less current according to the resistance of the temperature of whatever it is that you're measuring. So that they're used sometimes in the feedback loop of the control system. But anyhow, have a basic idea of what a PTC and NTC is. Okay. Now, a couple of questions on the CET and the employee entry examinations or quizzes. We'll combine a couple of different topics. And there'll be 2 or 3 layered questions where they'll ask you something, but you have to be able to put 2 or 3 concepts of electronics together to answer the question. For example, a good question on the CET, and I've seen it almost every time, is what happens to the current carrying ability of a wire as the temperature increases? Well, first you need to know, how does a piece of copper wire behave? Well, copper wire behaves like a positive temperature coefficient resistance. So what does that mean? Well, when the temperature goes up, what's going to happen to the resistance? Well, the resistance will also go up. So wire, when it gets hot, it increases its resistance. I don't know if you've ever noticed this or not, or if you've ever experimented with with those light bulbs in the lab room. Whenever you test those when they're cold with an ohmmeter, they read very, very low. But when you turn the light bulb on, under its operating conditions, when it's glowing, it has a very, very high resistance. So that would be a good example of metal. When it gets hot, the resistance goes up. So if I have an extension cord, look at number 14 here. If I have an extension cord and it's made out of copper and the temperature gets hot, what's going to happen to the resistance in the extension cord? Well, it should be very, very low. But as the wire gets very, very hot, the resistance will go up. And we know the current is equal to the resistance divided by the voltage, right? Nope. Oh, geez, that's not good. Okay. The current, I was just testing you. No, I really made that. I messed that up. But the volts divided by the resistance. And if the resistance over here goes up, and this over here stays the same like it does when you plug it into a wall, what's going to happen to the current? Well, the current has to go down. So your answer for number 14, what happens to the current carrying ability of a wire as the temperature goes up? Well, the current goes down. It'll carry less current, oddly enough. That's probably the reason why we have much fewer extension cords catching on fire compared to what we should have, the way that extension cords are overused sometimes. So the nice thing about an extension cord, it does have a little bit of current limiting ability to it when it starts to get hot, oddly enough. Okay, that concludes your first handout. Let's get the next handout. It's called Basic Electricity. Get that one out right now, and let's take a look at it. Basic electricity. Well, what's Ohm's law? Let's see here. V is equal to I times R, right? Now, interestingly enough, at PTI, we actually use the letter V, but what you're going to find out is once you get out there into the field, and maybe you've heard this before, instead of V, they actually use the letter E. So it's actually E equals I times R. Does anybody know why that is so? Well, here's the reason behind it. When you talk about current, the units of current are what? Well, it's amps. When you talk about resistance, I and R is what you find in the formula, but the units for resistance are ohms. Well, E represents electromotive force. That's electrical pressure. And electrical pressure, what are its units? V. So it's odd that we use a V in the formula in many books and at PPI. I never liked that. Just try to keep it to myself. But you're going to have to remember that with the CET, this is the formula for Ohm's law. Now, what are the three formulas for Ohm's law? Well, if we solve for E, this is the first one. E equals I times R. What if I solve for I? Well, divide both sides by R. So the volts divided by the resistance gives me the current. That was the one we just did on the other side. So that would be the second form of Ohm's law. And the third form of Ohm's law would be solving for R. So if you solve for R, you divide both sides of the equation by I. That becomes the voltage divided by the current. So those are the three forms. And they're going to be checking to make sure you understand that. These are easy questions. Do not miss the easy questions. Okay. Series bulbs, series circuits. A series circuit has one path. Let me see if I can draw you one. I apologize for my drawing ability here with the mouse. I've tried the scribe. The scribe's not any better. But here's three resistors, R1, R2, and R3. And they're going to be checking to see if you understand basic series operation. With a series circuit, you identify it because there's only one pathway for the current to flow. There's no breaks in the path, no nodes in the circuit. So what is the same for all components in the series circuit? Who knows the answer to that? Well, that would be the volts. Is that the correct answer? No, it isn't the volts. What is the same in a series circuit? It's the current. The current is the same. Now, what adds up in a series circuit? Well, many of you will say, well, the resistance adds up. Well, it does, but that's not what the question is getting here. First, what adds up in a series circuit? Well, right here is the total voltage, volt source, and the voltage on each one of these components has to add up to the volt source. So the voltage on each component adds up to the total source voltage. That's what a series circuit is. Again, a series circuit has the same current in all components, including the source. And what adds up in a series circuit? The voltage on each one of those components will add up to the source voltage. All right, what about a parallel circuit? Well, let's see here. A parallel circuit looks something like this. Here's a source, and they have a big parallel line across it, top and bottom. And down here, these are in parallel with each one of these. And what you'll notice right away with these resistors are they're all connected across the source. So what is the same for all components in a parallel circuit? Well, the voltage is the same. The volts are the same on all components in a parallel bank. Now, in a series circuit, the current was the same. And what added up in a series circuit? Well, the voltage did, but look over here. The voltage is the same here, so what do you think adds up in a parallel circuit? Well, it's the current. The current of the individual components. The current in here, the current in here, and the current in here will all add up to this total current right here. They all come together on this one node right here, and all the current adds up. So back here in the series circuit, V1, V2, and V3 added together equals V total. But here, it would be I1, I2, and I3 added together equals I total. All right, now, if you look at Ohm's law, if the volts remain the same, you have V divided by I equals what? Well, that equals the resistance. And notice that over here, notice that I is in the bottom, and you learned this in math class almost 2 years ago, and R is to the left. So what kind of relationship is anything in the bottom or in the denominator compared to the total value? Well, that would be inverse. So if the resistance goes up, if R goes up, what's going to happen to the current? Well, the current will go down. So if I decrease this value right here, that makes this go up. So higher current means lower resistance. Alrighty. You know, in a parallel circuit, if you remove a branch or one of the loads open up, in a parallel circuit, you have a higher resistance. That will make the overall current go down. Okay, so what's the relationship? They're inversely related. When one goes up, the other one goes down. Okay, now, another interesting question that you'll be faced with is constant questions about power. And what we find is, for any circuit at all, and I can have anything connected to this. Anything at all connected to this. I don't care what kind of circuit it is. I could care less. I can make it a really complex circuit. I think you're getting the idea here. And what I find out is if I measure right here the current, and that's called the source current, and if I know the voltage of this, I do not care what kind of circuit it is. It could be the most complex circuit in the world. But if I know the total current and I know the total voltage, I can find the total power of any circuit. So how do I find the total power of any circuit? Well, the power total, or the power of any circuit, is equal to the current, the total current, times the total voltage. So if I know the source voltage and I know the source current, I got it. Now here's another interesting aspect about any circuit that has any amount or arrangement of loads. If I know the individual powers of these, power 1, power and resistor number 2, power and resistor number 3, power and resistor number 3, 4 and 5. If I know the individual powers of these, and it makes no difference what their arrangement is, all I do is add together all of these individual powers, and that will equal the total current, total power rather. So what can be said about the total power and the power in each individual component for any circuit, whether series, parallel, or combination? If I know the individual powers being used by each of those loads, each of those resistors, if I just add them all together, I can get the total power of the circuit. So there's basically two ways to find the total power of any circuit. You can either use the total current times the total voltage, gives me the total power, or I can find the individual powers of each of the individual loads and add them together. That can also give me the total power. All right. I don't know if this is a new activity sheet or not. I don't think it is. I think it's just the flip side of that other activity sheet. But there are a lot of questions on here, maybe about 3 or 4% dealing with engineering notation and prefixes. And there are certain ones that you need to know. For example, here are the higher values down here, kilo, mega, giga, and tera. And here are the smaller values when you get below the basic unit, milli, micro, nano, and pico. And the conversions all revolve around moving the decimal places one way or the other to get a certain conversion. So, again, these are very, very easy questions you don't want to miss. These are the ones that every technician should know. For example, what are the 4 common prefixes used for larger electrical quantities? Well, the larger ones are kilo, mega, and giga. You won't see too much about tera every once in a while. So focusing on the kilo times 10 to the power of 3, 10 to the power of 6 for mega, 10 to the power of 9 for giga. Focus on those ones. Okay? So how about some conversions from the larger values? All right? I have 1,000 watts. All right, convert that to kilowatts. Well, here's what you should be thinking. Like the dollar, I have pennies and a dollar. And when I move from a smaller unit, such as a penny or a cent, to a dollar, I'm going to have a smaller number because the units are larger. So 100 pennies is a lot for a single cent, but $1 would be 100 pennies. So I have a smaller number because I'm using a bigger unit. So here I'm moving from watts to kilowatts, and kilowatts is a bigger unit. So what do I do here? Well, I move the decimal place, which is here, 3 places to the left to get a smaller number. 1, 2, 3. And so how many watts would that be? Well, that would be 1 kilowatt. Okay, now sometimes they'll say change 1,000 watts to megawatts. Well, when you look back here, you see mega is 2 steps from your basic units, which are right here. So kilo, mega, I got to move 6 places. What I would do if I were you, to make sure I don't miss these, remember the order of the units, and take it each step at a time. For example, first convert from watts to kilowatts, and then convert to megawatts. Well, 1 kilowatt, I have to move the decimal places 3 places more to the left to get to a bigger unit, mega. So 1, 2, 3. So my decimal point would be here. So what is my answer for that? 0.001 megawatts. So make sure you can convert back and forth. And these are the easy ones. You don't want to miss these. Anybody who's checking your test for correctness, you know, sometimes you can be close. You need a 75% to pass the CET exam. If you get a 74, sometimes they'll reevaluate it. But if they're reevaluating it to see how well you did, and then they see that you missed these really easy ones, then no way are they going to cut you a break. All right. What are the 4 most common prefixes used for smaller quantities? Well, let's take a look. The smaller ones will be milli. Smaller ones will be, let's see here. Smaller ones will be milli, micro, nano, and pico. Quite often we forget about the nano. You have to watch that one. -3, -6, -9, -12. And the way that you should think about these conversions are, if you go to a smaller unit, you're going to have a bigger number. So, for example, if I have $1 and I change that to cents, I'm going to have a bigger number because I would have 100 cents. Smaller units mean a larger number. So when you do these conversions, let's see here. Say I have to convert 1,000 milliamps into microamps. Well, this is a smaller unit, so I have to go 3 places to the right to get a bigger number. So what would that be? That would be 1,000. And then I have to go 3 places from where the decimal place is here. 1, 2, 3. So that would be 1,000 microamps. Okay? No, that would be 1 million microamps. And if I wanted to convert that into amps, amps are a bigger unit, so I'm going to go from milliamps to amps. I'm going to move 3 places to the left. 1, 2, 3. So that would be 1 amp. 1 amp is a big unit compared to a microamp. So microamps, you're going to have more. You're going to have more numbers for a smaller unit and less numbers for a bigger unit. Okay. All right. So hopefully you won't miss these easy questions. Notice everything that we talk about in this first, second, and sometimes even the third week are very, very easy. You're probably bored out of your daylights right now watching this with me. But it's a good review. It's like watching a movie twice. Sometimes you watch a movie twice, you pick up something you didn't see the first time around. All right, last handout, and then we'll get into a practice quiz, is doing some math. There is some math on the test. You're going to have to work with it. And they're usually very, very basic math. As a matter of fact, the math that you will see, almost all of the questions, 8 out of 10 questions, you can do them in your head. Now, I don't know if I mentioned it or not. You are not allowed to have a graphing calculator. You're only allowed to use your Texas Instrument 30, the one that you were given, or something simpler than that. So if you're in the habit of using a graphing calculator, I would say put that away and get your regular calculator out because you want to know how to use it on this test. Graphing calculators or any kind of calculator that can hold a formula or text are forbidden on the CET exam, and the proctor will check to see if that's what you have or not. If you don't have a calculator, we'll be scrambling trying to find one for you, so make sure you have a regular calculator. Do all the math with a regular calculator. Okay, we got to find the power in this resistor. Let's look at the circuit. Well, we know that the power is equal to the source current times the voltage And I see that I have the voltage, but I only have the resistance here. Now, some of you will use another version of the power formula, which is okay. That could be I squared R or V squared divided by R or something like that. But I like to stick with this one right here. So all I need to find is the current because I know the voltage. Try to stick with the simple formulas. So the current is equal to the volts divided by the resistance. And in this case, the power here would be 10 divided by the current would 10 divided by 5. And I have 2 amps for that. Okay, so the current is 2 amps. And the voltage here is 10. So 2 times 10, that has to be 20 watts for this particular problem. All right, show the math to find the power in this resistor. There you have it. Easy one. Okay, here's another problem that you're going to see. You'll notice that I will try to stick with certain problems. We don't have a lot of time to cover every situation. We only have enough time to cover what you will see on that CET or on an employee entry exam. So, take a look at this one. What are they asking? Be careful that you read the question closely. Don't assume things. Look, how much current is flowing? Not total current. What? They're looking for current in resistor number 3. So don't stop reading right here how much current is flowing. Notice, in resistor number 3. Okay, well this is parallel. In the parallel circuit, what's the same? The voltage, right? So the voltage in this case is 120 volts. All right. Now, what resistor is this? Well, this is the 2K. So the current, I3, the current in resistor number 3 is equal to the voltage divided by resistor number 3, which is 2,000. All right, what is the current there? Let's get the calculator out and check it out. All right, should be working these with us together. 120 volts divided by 2,000 ohms. I got 60 milliamps for that one. Okay. Now, look at this next question here. What is the total current? Be very careful when you read the questions. There's no leeway for you misinterpreting a question. The Electronic Technician Association knows that one of your skill sets, one of your skills in your skill set is being able to properly read textual information. So reading the question wrong is not a good excuse for missing it like it would be in class. Okay, well, the way that we could do this is we can find the current in here, the current in here, and the current in here, just like we did for resistor number 3, and then what? Then add them all together. We could do it that way. All right, now I'm looking at this. This one here is about twice as large as that. So the current in there must be about 30 milliamps. If I did the math for that, that must be about 30 milliamps for that one. And check this out. This one over here in the middle, that's almost 4 times the value of that. So that would be 60 divided by 4. Let me see here. Of course, you could do it any way that you want. There's a couple of different ways. That's around 15 milliamps. Because it's almost twice the value of this one. Not exactly because it's 8.2. I do see that. But sometimes doing these estimates will give you an idea of the right answer because it's going to be multiple choice and you're going to choose one. It never says none of the above. So you're going to get one that's close. So looking at the way that I did it here, 60 plus 30 is 90, plus 15 would be 105 milliamps. But let's see exactly what it is. Let's see here. Let's take the total resistance here first. Do the reciprocal formula for finding resistors in parallel. So 4 reciprocal plus 8.2 reciprocal plus 2 reciprocal equals reciprocal. And the overall resistance for this, if you did the parallel formula, the total resistance is about 1.15 K ohms. Now I can use that to find the total current. Okay. Let's see here. The total current then, IT, would be equal to the volts total, 120, divided by 1.15 K. Let's see how close my estimate was. 120 divided by 1.15 K. And it works out to be 10.4 milliamps. That was pretty close. I mean 104 milliamps. Pretty close. All right. Now, the answers would be something like 60, 30, 15, 104, because I just picked the closest answer. All right. What is the power in each resistor? Okay. Well, my total circuit power is going to be, let's see here, I'm going to use for the total power total. That's going to be equal to I total times V total. And in this case, 104 milliamps times 120 volts. I'm doing this on my calculator. You should be doing it as well. I got about 12.5 watts. 12.5 watts. Now, what did we say about the power? Well, we can find the total power by using the total current, the total voltage, or we can find the power of each resistor and then add them together. Let's see what that works out for. All right, the power in R1. Well, that would be over here, 30 milliamps times 120 volts. Let's see here, 30 milliamps times 120 volts. What do you get for that? 0.03 times 120. That's 3.6. 3.6 watts. Okay? The power in resistor 2 is approximately, because remember this is an approximate value up here. We made an approximation for this, about 50 milliamps times 120 volts. Okay? 15 milliamps times 120. Let's see here. Okay, I got about 1.8 milliamp, 1.8 milliwatts. I mean 1.8 watts, I'm sorry. All right, now the power in R3 is going to be its current times its voltage. So its current is 60 milliamps times 120 volts, 7.2 watts for that one. Now that better be, when I add these three together, this one, and this one, that better be pretty darn close to that. Let's see what it works out to be. Keeping in mind that the current for R2 was an estimate. 3.6 plus 1.8 plus 7.2. How about that? I got 12.6 watts, so that's good. All right, there you go. What do you think so far? Is this all coming back to you? Is this a good review? I don't know. Maybe some of you are thinking you got cheated because you don't remember any of this. Actually, you've been using it the whole time, haven't you? All right, there are some questions on the CET regarding a rheostat and whether you know what it is or not. But all variable resistors, when you see them, they always have 3 terminals on them. Okay, you have an outside terminals, which if you measure across the outside terminals, you're going to get the resistance of the potentiometer. And then you have a third terminal, which is typically in the middle, right here, a third terminal. This one is called the wiper. This one is the wiper, the one that you can move. If you move it one way, the wiper moves over this way, and it makes the resistance between here and here less, but between here and here more. Okay? Now, there's different ways to wire these. If I use all 3 terminals separately to separate parts of a circuit where none of these are connected together, They just simply call it a potentiometer or a variable voltage divider because you're using all three terminals. You essentially are splitting this up in here to two different resistances. Another way to wire this, though, is to actually tie this wiper to one side of this potentiometer. And when you do that, you actually end up with just a pure variable resistor. Okay, now some questions in the CET will revolve around your understanding of a rheostat. A rheostat is wired like that. When you see it wired like this, it's a rheostat. Another way that you'll see it is you'll see it wired to the other side, over here, like that. When you see a variable resistor or a potentiometer wired like that, it's called a rheostat. And a rheostat, you're actually using two wires, this one and that one. Okay, so that's what a rheostat is. A rheostat is a potentiometer wired as a pure variable resistor. All right, so you're going to see some math with the rheostat. Let's talk about it a little bit here. Look at this circuit. It's a little bit complex, is it? I don't think so. I'll tell you how to solve this. Ignore this one here for a minute because that's how we're going to reduce it. The circuit you want to look at is the one over here. This is the circuit you want to look at, that one. Now, let's look at the information that they're giving us here. R1 and R2 and R3 are both 5K resistors. So this and this are both 5K. These two are both 5K resistors. Not together, just each one is 5K. Let me write it in there for you. Okay. So 5K for this one, and 5K for this one. Okay. Now, they're telling you up here that the battery or the voltage source is how many volts? Well, it's 25. So over here, this is 25 volts. Okay, now what else is given to you here? Well, the information given to you is that there's 5 milliamps flowing in the circuit. So in this circuit, the total current coming out of this rheostat or coming out of the source here, the total is 5 milliamps. You can write it in. You're allowed to write on scratch paper when you're on the test. Okay, let's talk about this for a moment. Probably one of the harder problems to solve, although it should be quite easy for you. What you need to find here is, I know the current and I know the voltage. The first thing I need to find is the total resistance. Let's do that. Well, the total resistance, RT, using Ohm's law, is equal to the volts total divided by the current total. Okay, the current total is 5 milliamps. Do the math. 25 volts divided by 5 milliamps to see what the total resistance of this circuit should be. 25 volts divided by 5 milliamps. I got 5 kiloohms. Okay. Now, you know the total resistance should be 5 kiloohms. That's what the total resistance has to be of this whole big circuit. This whole circuit with all of these put together is 5K. So to generate that current, I need 5K and 25 volts. Now, this is a two-step problem. First you found the 5K. Now, these two resistors here, this and this, wouldn't these boil down into one resistor over here? Wouldn't that be R3 in parallel with R4? Let's make it into a simpler circuit. So I have, not only do I have R2, that's in parallel with R3, right? Now think to yourself, how do I find the parallel resistance of a 5K in parallel with a 5K? Do the math for that. How do you do that? Come on, how would you solve two resistors in parallel with each other? Well, wouldn't that be the reciprocal of 5K plus the reciprocal of 5K equals, take the reciprocal? Well, what would that turn out to be? Do that math. Well, as it turns out, that's going to be 2.5K. All right, now this resistor up here represents the rheostat. They're asking you, look at the question. What must be the value of that rheostat? What must be the value? Well, my total resistance has to be 5K. That rheostat R1 right here is set to a certain value. Don't be fooled by the schematic. It's just a variable resistor up here. You know, we talked about what a rheostat was. A rheostat is just a variable resistor. Okay, what is the value that has to be? I need a total of 5K. These two together are 2.5K. We don't have to add 2.5K to get this value. Well, 5K is the total. I'm going to subtract 2.5. What does that have to be? Well, of course, R1 has to be equal to, it has to be set to 2.5K. Because 2.5K plus 2.5K equals the 5K that we need to generate the 5 milliamps with 25 volts. Now, think about it. This is a 2 or 3 layer problem. This is a really good problem that they're checking to see if you know how to put concepts together. First, do you know how to find the total resistance? Second, do you know what a rheostat is? Third, can I solve parallel resistances? Fourth, do I know how to find the total resistance given the voltage and the current? So you need to put all of these things together to solve these multi-layer problems. They say that this kind of problem is a very high-order thinking problem. You just don't do one thing and get the answer. Yes, 70% of the questions on the CET will think and get the answer in one step. But the remaining ones will be a little bit of thought process put together to show that you know how to manage your skills as a technician. All right, guess what? We're on to the practice quiz. We're getting really close to the end. Let's see if we can put together what we know here. Let's see if we can put together what we know. Go ahead, look at number 1. And over here are the possible answers. These questions I'm going to present to you are very, very similar to what you will see on the CET exam. You're given a question, sometimes it's a little bit tricky to read it, and then you're given answers. And you need to pick an answer. It'll be on a computer. You're going to have to pick a good answer on the computer. All right, look at the circuit below. Get your calculator. I want you to answer these. I will put these answers on the Blackboard site later. Okay, but right now I want you to work through it with me. Look at the circuit below. How much current is in that resistor? Well, E, the voltage is 10, and R is 5. What would that be? Well, if you got 2 amps, you got 1 out of 1. You got 100% so far. Every time you take these practice quizzes or a real quiz online, you should be striving to get 8 out of 10 right every time. Okay, look at the circuit below. Look at the circuit above again. How much power is in the resistor? Well, we said we had 2 amps and 10 volts. How much power would be in there? 2 times 10. 20 watts. There you go. And I'm going to tell you something here. These old guys and engineers that write these quizzes and tests, they know how to punch it in incorrectly. So you can be sure if you mix your math up, you're going to get one of these crazy answers. And you'll be answering that if you don't know what you're doing. So you have to be careful. You can be sure that every time you do this math incorrectly, you're going to get an answer, and one of them answers will be the incorrect answer. You've got to watch for the right answer. Okay. Which of the following circuit configurations have the same amount of voltage across each component? Let's see here. Did we cover that? I can't remember. Let me see. I have to draw on my own knowledge here. Is it? Oh, I don't know what the answer is, but this looks like a good answer. Y delta. I wonder if I should answer that. Y delta. Ooh, that sounds really good. You see, that's a distractor. Y delta. Okay. So what is the correct answer? Of course it's parallel. We know that. All right. Copper wire. Copper wire exhibits what type of temperature coefficient? ATC, NTC, PTC, CTC, or WTF? Which one of those? Well, did we even talk about this? No, we didn't. Did we even talk about that? We didn't. Did we talk about this? We did not. So right off the bat, I'm showing you how to solve these. Use process of elimination. Get rid of the ones that you know we didn't talk about or that pertain to that. So we have to choose between these two. What does copper wire do? Does it increase its resistance with heat, or does it decrease its resistance with heat? Well, copper wire exhibits a positive temperature coefficient. Your answer for this would be C. All right, look at the circuit below. The voltage is 10. R1 equals R2, which means these are 10 ohms each, not 10 ohms total. Watch out for that kind of wording. R1 is 10 and R2 is 10. These are both 10 ohms each. So how much current is flowing in R1? I have 10 volts here, and R1, the current only in R1. What is the current only in R1? You got to watch. You got to watch and see what they're asking for. Well, 10 volts divided by 10 ohms, that's going to be how many amps? 10 divided by 10. Well, that must be 1. And look how easy the math is on these. A lot of times you don't need to use your calculator, but if you want to make sure, use it. Sometimes you don't want to run into the situation where you guess with the math in your mind. Do the math if you have to. It's okay. Now look at the circuit above. How much total power is dissipated? Well, if in there we have 1 amp, how many amps has to be flowing in that one? Well, they're both 10 ohms, so what do we have? We have 1 amp here. We have 1 amp here. So the total current is going to be what? It's going to be 2 amps. All right, now I know the current, and what is the voltage? Well, the voltage is 10 volts. So 2 amps times 10 volts, that must be 20 watts. All right. Another way to solve that is, you know, if you're familiar with other formulas, and I should tell you this, there's never just one way to solve math in electronics. There's always many ways. So if you're comfortable doing it another way, fine. Just make sure you get the right answers. Okay, how about if I took the reciprocal of both of these and add them together, the ohms, that would give me, and I think I would get 5 ohms for two 10 ohm resistors in parallel, and 5 ohms with 10 volts, 10 divided by 5 ohms gives me 2 amps. I could get it that way. Or I could use, let's see here, V squared divided by R. Okay, that would be a power formula. Or I could use I squared times R. So, you know, there's many ways to find power, but we try to stick with the easiest way. How are we doing so far? Do you think you would have got these all right so far? These are the easy ones you don't want to miss. All right, number 7 here is dealing with Kirchhoff's voltage law. Look at the circuit below. The total voltage is 40. The voltage on R1 is 10. What must be the voltage on R2? Well, we know that these two voltages have to add up to total. So if this is 40, I have 10 on R1, and then I have how much here then? Well, 40 minus 10, that must be 30 volts. So my answer for that one would be 30 volts. VR1 is 10 volts, E is 40. those two voltages on R1 and R2 have to add up to the source. It has to be 30 volts. All right, now check this out. In number 8, they're saying, look at number 7 again. If R1 is 5 ohms, oh, look, they're giving us a little bit more information. We have 5 ohms here for this thing. All right, what else do I know about R1? Well, I know that R1 has 10 volts on it. All right, now this question will take a couple of different forms. They might say, what is the current coming from the power supply? Or they might say, what is the current in R2? Well, we know that the current is the same in the series circuit. So if I find the current here, I know the current here or there. Okay, well, what's 10 divided by 5 ohms? There must be 2 amps flowing in there. 2 amps in R1, 2 amps in R2, 2 amps total. I think I'm on the right track there. 10 volts divided by 5 ohms, yes. All right, so there's 2 amps flowing. I have 10 volts applied. What is the current, what is the power going to be dissipated by R2? A little tricky there. If I take 2 amps times my source voltage, 40 volts, I'm going to get the total power. But are they asking for the total power? No, they're asking for the power in R2. So, focus in on that particular component. Focus in on R2. Well, the volts on R2 is equal to what? What do we find for R2? 30 volts. The current in R2 is what? Well, series circuit, it's all the same current. And we said how many amps was that? We say it was, okay, it was 10 volts over there, divided by 5 ohms, so that was 2 amps. Okay, so 30 volts times 2 amps would give me 60 watts for that one. Alrighty, so 10 volts. Yes, okay. I'm looking at the overall value. I'm looking here now. I'm making some other determinations here. 40 volts times 2 amps would be 80 watts. It's 80 watts total. So the power on R1 must be 80 minus 60, which would be 20. And so 10 volts times 2 amps, that would give me 20 watts on R1. So that does all make sense. See, I'm putting it together, trying to make it sense. Oh no, look at this. Where do we see this before, huh? Okay, what do we got to do here? Look, the battery is 22.5 volts. R2 equals R3, which are 5K each. Both R1 and R2, whoops, that's not right. Hold on a second. This is I got to fix this. This is a bad question. Okay. This should say, I'm sorry, fix this. This should say R3. So fix that. That's a bad one. Fix that on your activity sheet. Cross off R1 and then write in there R3 and R2 are 5K each. Okay. That's confusing, isn't it? Okay, so what is this? Let's see here. I apologize for that mistake. R2 and R3 are how many K each? Well, they're 5K each. Let's write that in. 5K. What is 5K in parallel with 5K? Well, we did that before. 5K in parallel with 5K would be 2.5K. Okay. And here we have to find out what is the value of R1. That's that potentiometer. Look, you can recognize it as a potentiometer. Got that loop on right here. So what is the setting for R1? Well, we know that the current is 4.5 milliamps and the total voltage is 22.5. So let's find RT. My total resistance for the whole circuit is going to be 22.5 volts divided by 4.5 milliamps. What's that give me? Let's see here. 22.5 divided by 4.5 milliamps. Well, how about that? It works out to be 5K. All right, now look, I have 2.5K here. What does this have to be set at to get a total of 5K? So I can generate 22.5 volts and 4.5 milliamps. Well, what added to 2.5 will give me 5K? Well, of course, the answer there is 2.5K. All right, I'm sorry about this problem up here. In reality, you can just cross this whole thing off right here because all the information that we need is right here, that both of those are 5K. All right. I won't be able to change it on the Blackboard site, but I'll change it for future courses, which you will not be involved in. But so it's not going to help you. So go ahead and fix that. Cross off up here. Cross off this stuff right here. This should not even be in there. This should have been erased. All right. That's your 10 questions. Would you have been able to get a 10 out of 10 on that? I don't know. Should have. You know, we're starting with the easiest stuff. Okay, let's wrap this up and get out of here. And then I'll put the answers to the practice quiz online in a couple of days. And then come Friday, I will turn on the actual online quiz the same day I put up the answers for the practice quiz. And I'll put on the answers to the activity sheets as well, so that if you didn't get every answer here for our activity sheets, you'll have them. If there's any questions, you have to ask me by email. So read the introductory email I sent you one more time. Get all the information you can out of that email. It's actually the introduction to the Blackboard site as well under the Introduction tab. All the documents do not appear at the same time in the Blackboard site. I'll release them a little bit at a time. The reason is I want you to do the work. If you don't do the work and you're just going around writing in answers all the time, you're not going to pass the CET. I'm trying to get you to learn how to absorb and put into your permanent memory the kind of things that you are going to find. So review the documents as they appear. Not all the handouts will be released at the same time. The first things you're going to get are you're going to get the answers to the practice quiz. And then you're going to get the answers to the activity sheets. And then I'm going to give you the online quiz. The online quiz has to be completed before Monday night. And then the following Monday, the next day or Monday night, I will put the answers up to the actual quiz. So you'll have everything you need to make a test bank. I know you can't print off the practice quiz information here, but the one that I will post will have the practice quiz and the answers on a separate piece of paper. All right. All righty. So start creating a test bank for yourself of practice and real quizzes. And, the way that I wanted you to do that was to cross off the ones that you know the answer to. Don't waste your time studying the ones you know. That's ridiculous. But circle the ones or emphasize the ones or yellow out the ones that you don't know and study those. And once you know those, go through them after you study them and see if you can answer them and get the right answer. If you can, cross those off. You're going to have around 200 total questions at the end of the quarter. You need to start doing this now. You don't want to be waiting to the end of the quarter. You will not pass the exam if you cram. Hey, it makes a rhyme. You should realize you won't pass the exam if you cram. You got to do it a little bit at a time. If you do it a little bit at a time, it's very, very enjoyable. If you try to cram it in, it becomes a big, massive task. All right. Now, also, you have to do the online quiz by Monday. It's your grade for this class. You need a 60% or above to pass this class. So get that online quiz in by Monday. If you don't do it, I have to give you a 0 for it. It will be shut off on Monday, and the test is timed. I'm only supposed to give you 10 minutes to do it, because on the CET exam, you're allowed about 1 minute per question. And that's why I talk with you about ways to easily solve the question without doing a lot of math. Now, finally, before you come around for the next Collaborate video to watch, which will be put on next Tuesday, I'll do the next Collaborate video, which will be next Tuesday. That'll be the beginning of a new cycle of weekly information. Next Tuesday, we'll talk about some basic components, transformers, inductors, and capacitors as they apply to DC current and DC voltages. That'll be your Collaborate for next week. And then we'll go through this whole schedule again. We'll do the, hopefully by Monday night, you'll have done the previous quiz for the week 1. And then week 2, we'll do the Collaborate. I'll have the handouts for you. We'll do a practice quiz in the Collaborate video. You'll get the answers to the activity sheets in the video. You'll have to do an online quiz by the following Monday. And then I'll give you the answers to the online quiz. By the way, when you take the quiz, they're going to tell you what the answers are too. So, if you want to do that, that's okay. It's hard to write them down, though. I'd be careful with that. When you're trying to take the quiz, it's hard to write them down while you're taking it. Don't do that. Just answer the questions, because you only have 12 minutes for the quiz. But when you're done, they have, once you click through the quiz, they will tell you which ones you got right and which ones you got wrong and what the answers are. So you could possibly copy and paste that into a Word document or write it down, whatever you want to do. But no worries, because I will post the quiz actually with its answers on the following Tuesday onto your Blackboard site. Okay, I think that's it for today, isn't it? It looks like that it is. I'm clicking on this. It's not going any further. So hopefully this wasn't a total bore for you. I see that it's gone about an hour. I'm going to try to keep them all at about an hour or less. I'm not going to make them real long. Today was a little bit longer than it would normally be, because there's a lot of introductory information that I presented with you about how to do things. So other than that, I hope that you've renewed your, reviewed some information here, maybe some things that you forgot. But keep in mind, you don't want to miss the easy ones. Get all the easy ones right. If you get all the easy ones right, you will pass the CET. And by the way, anybody can sit for the CET exam, and I'll be able to tell and give you a heads up in my opinion on whether or not you will pass the CET come the end of the quarter. But generally, if you get a 7 or an 8 on every one of these quizzes, or most of them, you're going to pass the CET. And I will give you 2 big tests at the end of the quarter that I want you to, they're practice tests for the CET exam, and those will actually give you a feel of your overall score. They're very, very similar to what you're going to be tested on. So that'll be at the end of the quarter. We won't worry about that, but the way that it works is, if you want to take the CET exam, you bring $60 cash or check, and if you pass the exam, we'll know on the spot. We just give you your money back. And generally, you'll be able to tell if you're going to pass or not by the end of the quarter. I have a good idea. I've been teaching this class for a long time, and I will be able to give you my humble opinion as to how you will do on the CET exam. Okay. Other than that, I've talked your ear off. I thank you very much, and I will talk to you next week. And don't forget, you can always email me at mcneil.dennis, there's 2 L's in McNeil, at pti.edu. You know that the email will eventually change to ptcollege.edu for you and for me. I think it's at August or September, so we have to watch for that, the email thing. But for now, pti.edu will be okay. Well, you can just return an email to me on one of those emails that I sent you. Okay, that's it. I hope to talk to you all in the future. And let me know if everything's going okay. And we're done.